YouTube channel afterwards. Okay, you are screen sharing, and I hope I am recording as well. Looks that way. Let me just double check to make sure. We haven't used Teams that often. You know, we've been using it. I'm sorry, we haven't used Zoom that often. We've been using Teams. So it looks like, yeah, it's good. It's changed to pause recording or stop recording. Okay. So anyway, I want to welcome those of you who, let me admit some more people first. Hang on. Excuse me. Okay, I want to welcome everyone to this month's meeting of the Nashville Microsoft Azure User Group. That's the URL to our meetup site at the bottom of the screen, and also a link to the YouTube channel where we post all these meetings. And we'll post this one as well afterwards. So you know, that's basically it. You are being recorded, so you are now forewarned that you are being recorded. Okay. Let's get the cursor and do this. Beg your pardon? Okay, if you're not gonna, you know, if you don't have a question or you're not gonna speak, please go on mute. Anyway, this is the mission of our group, which most of, I'm sure, you pretty well know by now. We're everything about Microsoft Azure. We're all about supporting our members and providing a facility for our members to network with each other and find out about Azure. We cover all kinds of topics. We cover infrastructure topics, developer topics, management topics, whatever, you know, whatever people have an interest in. And if you have an idea or a suggestion for a topic, let us know. We're always open to suggestion. So this is our logistics screen. As we used to meet every third Thursday of the month over at Microsoft, but since the pandemic, we've started meeting virtually. When we met on premises, we had, you know, excuse me, in person, we had food provided by a sponsor and a main meeting topic, which we still have. Now our meetings are online only. Just a couple of facts about the group. You know, one fact about the group anyway. We have over 1,600 registered members, and the number's going up all the time. But we can still use more members. So tell your friends and coworkers about us. And again, like I said before, if you have a topic that you're interested in, let us know, and we'll try to accommodate you. So this is our board of directors. I'm one of the original founders. In fact, you have two of the original founders here tonight, I see, myself and Roger Dahlman. Hi, Roger.
Hey, how's it going?
Good, great. Good to see you again. And, you know, I'm the founder and the president, and by day, I'm a cloud solution architect with Red Apt. We're a consulting firm, a good-sized consulting firm. And Roger is the co-founder. He and I started this group back in 2013 with 4 members, and now we're over 1,600. So we've come a long way. And Roger by day is an enterprise architect with Deloitte here in Nashville. Also on the board of directors, we've got Tim Warner. Most of you probably know about Tim or have heard about Tim one way or another. Tim's a Microsoft Azure MVP and a very prolific Pluralsight author. Most of the courses on Azure that are out there in Pluralsight, you know, Tim created a lot of those courses. And that's someone asked me earlier about references and learning. If you do have a Pluralsight subscription, there's a ton of stuff on Azure out there. In fact, there are also a bunch of free Pluralsight courses that Microsoft is providing with Pluralsight on Azure. So anybody who wants, I guess what I'll do is after the meeting, remind me, and I'll post a link in the chat. I'll post a link in the meeting, in the meeting notes, so that you can see who, where you can find that information. Excuse me. And this is Tim's link, trainertim.com. He blogs and posts, and he's on Twitter. A lot of information. Akila Alred is a board member, and she's our director of academic outreach. So she works with all the colleges and universities here in the Nashville area, and we have quite a few, recruiting folks to come become members of the Azure group. Matthew Puckett is our meeting space sponsor. Matthew started with us way back in 2013 when we started, and he's been, providing space at Microsoft for us ever since. By day, he's a Microsoft National Cloud Solutions Architect. And our VACO sponsor is, sponsor, as we'll talk about in a minute, is for refreshments is VACO, and Jack Hagler is on our board as well from VACO. And they've been our permanent sponsor for 7 years. So it's been a great relationship. I remember running user groups in the past where I had to always hustle and try to find people that would provide pizza and refreshments for our meetings. So, it's been great to have them. And speaking of sponsors, I do want to shout out to our sponsor. There's Microsoft, as I've said. They're the permanent meeting space sponsor for when we meet on site. VACO is our permanent refreshment sponsor. And as you probably have figured out by now, it's a little hard to provide refreshments to a group that's meeting online. So what they're doing is they're actually providing this Zoom subscription so that we can, have our meetings online. And Red Apt is a sponsor because they provide my time for running the group. They let me work on the group sometimes during working hours, sometimes not. And the Greater Nashville Technology Council, which is an organization of of a lot of companies in Nashville, and they support, in addition to supporting technology in the area, they also support all the technology groups. Okay. We haven't done a lot with sponsorship lately because we're not meeting on site, but if you are interested in sponsoring a meeting, we've got something of value that we could raffle off or give away to our members in exchange for 10, 15 minutes to talk about your company at the beginning of the meeting, contact Roger Dahlman. That's Roger's email address at the bottom of the screen. So we've got upcoming meetings. Well, we have one upcoming meeting because so far we're not really scheduled to have a meeting in December because it's pretty close to Christmas. But January 21st, we're going to have a presentation on machine learning. And this sounds like a pretty interesting talk. So I'm looking forward to it myself. So that's the schedule. And now what I'm going to do is I'm going to turn the floor over to our featured presenter for the evening, Chris Smith, who's a solution. Chris can tell you a little bit more about himself, but he's going to talk about Terraform and Azure. So let me stop sharing. And Chris, can you share?
Yes, indeed.
Okay.
Okay, let me share my screen here. Oh, host disabled participant screen sharing. You got to get it right.
I stopped sharing.
No, I know, but I don't have the right to share.
Oh, you don't? Okay, hang on. More. Allow, make co-host. How's that? Will that do it?
That should do it. Okay, thank you.
Great.
Let's give this a shot now. Okay. Okay.
Yep, see it.
Where is?
Yeah, we see your deck, not the presentation. So.
No, we're good. We're good.
Okay.
I was trying to find the chat window so I can put that up. Okay. So we are going to talk today about Terraform in Azure. While I'm doing the talk, if you want to just shoot questions into the chat window, I'll check it time to time so I can come back and answer some of the questions you guys might have. Before we start, if you would, if you could put in the chat window from 1 to 5, your knowledge of Terraform, with 1 being I've heard the term and 5 being I use it a lot, just so I have a general idea.
Keep it coming. And again, other vendors out there, Mesosphere or Rancher, that give you the ability to run different factions of the ring.
Okay.
And now these are the ones that are available out there, not necessarily first class service. So let's get.
Okay, so It looks like there's a good mix. There's some threes in there, some twos, some ones. So I'll try to accommodate everybody here. Okay, so this is me. I am Chris Smith. I'm the Senior Solutions Engineer for HashiCorp, covering the Tennessee and Kentucky area. I am new to this area. I'm originally from the Washington, D.C. area, but my wife grew up in Nashville. I met her in Maryland, and a few years ago, she decided she wanted to come back. Kind of had to drag me a little bit, but it worked out. I love it here. I've been in enterprise IT for 22 years. I've done basically every hands-on job you can have. I've been a data center guy. I've been a sysadmin. I've been a DBA. I've done development. I worked in DevOps. I've worked for small companies. I've worked for big companies. My last job was running a DevOps team at IBM. And I've been with HashiCorp now for about 6 months. Contact information is on the screen. So let me tell you a little bit about HashiCorp as we get started, kind of who we are as a company and what we do. HashiCorp was founded in 2012, but has really grown in the last few years. We're up to just over 1,000 employees now. I think somewhere near 1050. I'm number 942, I think. What we do is we seek to automate cloud workflows. We want to make people's transition to the cloud easy, and we want to help people get the most out of the modern data center and the modern cloud experience. That includes cloud vendors such as Azure, Amazon, Google, but also people who are modernizing their data centers to make them more agile. People using things like VMware, Cloud Foundry, things like that. So we have a number of software products. We're an open source company. The list on the right, we have open source versions of all of those products. 2 of them are relatively new, Boundary and Waypoint, which were released about a month ago. Boundary is an access provider. Waypoint is an application distribution program. 4 of those programs we have enterprise versions of. Terraform, which is for provisioning, Vault for security, Console, which is for networking, and Nomad, which is an orchestrator. But all of those programs, even though they have enterprise paid editions, have fully featured OSS editions, which you can download today and explore if you want to. So when I say we're helping people with the migration to the cloud, we're talking about people who are in like a traditional static data center, the kind of environment where things are very long-lived, they don't change very much, there's a lot of manual processes. And in the last few years, we've started to see a move towards a more modern, dynamic data center. As I was saying, even people who are, people staying on site in their data centers are starting to use, VMware, PCF, starting to automate that way, and they're starting to move systems of engagement to public cloud, such as Amazon, Google, Azure. Well, different environments means you need different tools. Your processes are going to change. Whereas your security might have been IP-based, now it's a low trust environment. It's going to be more identity-based. Whereas you before were, having to deal with ordering servers and racking and stacking and cabling. Now, if you want to provision infrastructure, it's more on demand. So your processes have to change. And the cloud providers are well aware of this. They want you to come on board. So they've built tools to help you adapt to this new environment. And these are good tools and they work. But each environment has their own kind of tool. If you're going to be worried about identity on AWS, you're looking at IAM. If you're on Azure, you're looking at Azure AD. So you don't really have a tool that handles these workflows across all these platforms. And that's really what HashiCorp is out to do. I'm not going to talk your ear off about what the company does, but just keep that in mind as we talk about moving from kind of a more static, traditional data center environment into a cloud-enabled, more agile, low-trust environment. We're looking to provide tools that work across multiple clouds and really are developer-centric to provide agility and security to provide these workflows. All right, so tonight we're going to talk about Terraform, which is our provisioning workflow tool. And it really comes down to infrastructure as code, which is a term that you may or may not have heard before. So we're going to talk a little bit about what building infrastructure was like. And this kind of dates me as an old guy. But when I first started for a company called Digex in the late 90s, we were doing dedicated hosting. And customers would come to us and say, you know, we want to put 20 web servers in your farm. They put in a server order form, and we'd promise to have it stood up in 20 days. And a guy like me would come in at 10 o'clock at night, and I'd have a stack of build sheets on my desk, and I'd go back into the warehouse, and there would be boxes upon boxes upon boxes taped together with moving tape. And that was what I'd have to do. I'd have to unpack the boxes, have to, you know, rack everything, run cable, do builds. And that's what builds were like 20 years ago. And it's progressively increased and gotten better and better, right? We started seeing more automated hardware builds, things like network builds, plug it into the network, server builds itself. We started to see virtualization, you know, things like VMware and using kind of golden images that you could duplicate and build that way. Then we started seeing virtual networking, right? Software-defined networking. So the velocity of being able to do these builds has been steadily increasing over the past 20 years. And that's when the cloud hit. And the cloud is kind of like a tsunami, right? The cloud is unlimited resources, and it's almost unlimited velocity. If you want resources, you want infrastructure, you can build it. You don't have to order it. You don't have to wait. You're paying as you go. It's a completely different model. But because it's a completely different model, it's going to give you different challenges. And I think it takes some time for people to kind of get their hands around that and realize that it's a different way of doing business. But it's a good way of doing business. Just this image right here, having the ability to manage all of my infrastructure kind of from one console is just a great thing, and something that I could not have imagined earlier in my career. So how are you going to build out these resources? You know, you have a number of options. They make it awfully easy to build these things manually. You can go into the Azure console, push a button, say, I want some compute, and it's going to give you a form that you can fill out. The problem with filling out forms, even though it's much, much faster than what I was doing in the late 90s with my build sheets and my boxes and my tape, it's still slow for really what cloud is. Also, it's difficult to be precise, to get the same thing every time. And if you're filling out a form over and over again, there are going to be mistakes, which kind of leads to special snowflakes and operational problems. They also give you an API to work with. An API, it's nice, right? You can automate, you can build automation to build resources for you. But the API is really just an endpoint. It's something that you need to build layers on top of. So you're stacking your own code on top of the API, and that's great. It's going to do what you're going to do. But then you're going to run into management overhead for that code. So you really kind of need something that's in the middle of the API and the UI. And that's really what infrastructure as code is, right? Infrastructure as code is the process of managing and provisioning cloud infrastructure through code. It gives you what we call executable documentation. And a lot of times, you know, people say my code documents itself, and you know that's not true, but this is, you know, this is better than nothing. And it empowers provisioning workflows with the benefits of a software development lifecycle. And the benefits of the software development lifecycle are huge. And we're really going to see that once we start talking about Terraform Cloud towards the end of the presentation here. So what does infrastructure as code give me? Well, it provides a codified workflow to create infrastructure. So it allows me to build kind of take advantage of everything that we do when we're writing code. I can version codified infrastructure. I can look at it and see the kind of documentation that I have. It's more easy to kind of revert through like a version control system. So you get all of these advantages when you work with infrastructure as code. It allows you to change and update existing infrastructure, right? It's not like, you know, a script that you're running against an API where if you say build a server, it's just going to build one server every time. It allows you to be deterministic and kind of make deterministic changes to what you want to do, to look at what you've already built and add to it or change it as necessary. Infrastructure as code is going to allow you to integrate with application workflows, right? If you've got scripting, if you've got CI/CD, other processes can use infrastructure as code-based systems to call those systems and kind of integrate with the rest of your business operations. it allows you to provide reusable modules for sharing and collaboration. Anybody with a programming background knows how huge that is, right? You're not writing sorts, you're not writing filters, you're using code that already exists that somebody else has built and packaged, that's been tested, that's performant. And this allows you to take infrastructure as code, allows you to take that kind of concept from development and build out these reusable modules to let everybody in your organization do the best practices that you spent time setting up. Infrastructure as code allows you to enforce security and organizational standards. It makes it easy to put guardrails around what people are doing. We'll talk about that in a lot more detail later. And it allows collaboration between different teams. It makes it easy for different teams to work on the same project because it's just different people updating code. So Microsoft Azure, which we're here to discuss, being as this is the Nashville Azure user group, has a functionality for infrastructure as code, and it's good functionality. There are ARM templates. They have a library of ARM templates where you can go through and say, this is a suggested template for a server. This is a suggested template for a network. You can go to existing resources that you have in Azure and go through and say, build an ARM template off of this. So there is functionality within Azure for ARM templates. It's big and kind of clunky JSON. It's really kind of hard to read, but it absolutely works. So then there's Terraform, and Terraform is HashiCorp's tool for infrastructure as code. So Terraform is an open source binary. It's an open source project. We have contributors. It's a very well contributed to project on GitHub. It's distributed as a binary for Windows, for Linux, for Macintosh. And it serves multiple clouds and multiple providers. And this is kind of what sets it apart from those ARM templates that we looked at. Those ARM templates that we looked at are going to work on Microsoft Azure. Terraform works across clouds and across providers. I'll show you a little bit about this when I demo it, but we have a registry that is maintained by our user community, but also by these companies that we partner with, who keep up to date these provider code for accessing and for building out resources for their environment. So with Terraform, you can build out Microsoft Azure resources. You could also build out Google Cloud. You could also build out Alibaba. You can build out Postgres databases. You can do work with Kubernetes. Datadog has a provider. There are literally hundreds of providers that you can use Terraform to build out infrastructure for. Terraform is deterministic, which means it doesn't look for you to tell it how to build something. It just looks for you to tell it what you want to build. Terraform will look at the definition of what you want and it will put it in place, and it will figure out how to put it in place. If you make the change to that, it'll look at what you already have in place and figure out how to get from your current state to your new state. So it's a kind of an easy tool to use that gets you where you're going without you necessarily having to know how it gets there. And I'll show you how it tells you what it's going to do. It's not a black box by any means, but it's a deterministic environment. You can build your own provider. There's documentation for building your own provider, and you can host that provider on the Terraform registry for others to use, or you can build it and host it somewhere privately. So there are options to go that way. Terraform is kind of easy to read and learn. If you look at the code on the right, that code by itself will build an Azure resource group, will build a Linux server that is accessible on port 22, we'll upload a public key to that server, we'll build a network, make that network accessible, provide a public IP to that server, and provide a private IP to that server. And that's 39 lines of code. So, and it's relatively easy code to read. Terraform is using something we call the HashiCorp configuration language because we thought JSON was a little bit too clunky. So this is a JSON-like language, but without some of those JSON kind of pain points. It's easy to look at HashiCorp Terraform code and really see what's going on. You can look at that network module and see that we're adding subnet prefixes, we're naming things, you can see what we're building, and you can see how these pieces relate to one another. Finally,
That's 100%.
I'm sorry? Okay, so finally, Terraform is well documented and it's proven. It's got a very large user base. A number of Fortune 500 companies, Fortune 50 companies rely on Terraform to manage their infrastructure build process. Terraform, Terraform Enterprise, and Terraform Cloud, which we'll get to a little bit later. And like I said, it's got a very, very large contribution base, and it's a proven asset that with a lot of documentation. We'll look at some of that documentation as we go. So what Terraform isn't is configuration management. Terraform is an infrastructure management tool. There are pieces built into Terraform to do basic configuration management, but we don't suggest people use it. It's there as kind of a bare bones. Really, configuration management is left best to configuration management tools like the ones on the right of that slide. Those tools similarly have infrastructure management tools, but they're really not built to do that. So really the kind of message we're looking for is that infrastructure management and the configuration management, you let each tool do their own thing and they're stronger together. Terraform has hooks to call Chef, to run Ansible Tower code. They're really not built to compete. They really work to complement each other. The last bit there, the mutable versus immutable, is an interesting concept. When you talk about configuration management, you're usually talking about mutable code. You're talking about an environment where you build a server and then over time you change that server to do what you want it to do over the course of the life cycle. The server needs to be patched, you run patches on the server, it stays in production. You have a new version of your code, you upload the code to the server, and it stays in production. And the problem with this is you tend to get these snowflake environments, these servers that aren't quite right. You know, one patch failed to install on this server and it rebooted and it was kind of hinky, but you know, it works well enough. And that's the server that always gets tickets in the middle of the night, things get a little weird. So in opposition to kind of that mutable model, Terraform kind of pushes towards an immutable model. And it's not something that everybody needs to use. It's not something that everybody should use. But the immutable model is more like building an image for what you need. Take your code, take your patch level that you want, build an immutable image, upload that to the cloud provider, and then Terraform, I need these. Terraform builds it out, throws it in the network. And when you're ready to do your next code push or you're ready to patch the servers, you create a new immutable image with that patch base, with that code, and just tell Terraform, rip all the old servers down, throw all the new servers up. So it's that mutable versus immutable thing. And when you're working with immutable flow, you tend to see configuration management tools involved with Terraform, things like Chef, Ansible, and Salt. But as you get to the immutable kind of paradigm, if that's where you want to go, Terraform can kind of do it all on its own. So why would I want to use Terraform on Azure? Well, first, we have a deep partnership with Microsoft. We're not competing with Microsoft. We're not trying to tell you you shouldn't use CloudFormation. Microsoft is not trying to tell you you shouldn't use Terraform. Microsoft in the template, the ARM template FAQ even specifically says, if you want to use Terraform, that's great. It's going to work for you. We talk to Microsoft regularly about Terraform usage on the platform. We work with Microsoft in development of the Azure provider for Terraform. So it's a tight partnership with Microsoft. And Microsoft has integrated Terraform into the Azure platform. If you go to the Azure Cloud Shell right now and type Terraform-version, Terraform is in the path of the Azure Cloud Shell. So Microsoft integrates Terraform into their platform. Terraform is available in the marketplace. Terraform is available, has pipeline components available in Azure DevOps. So Terraform isn't, while it is a third-party tool and works across all these environments, it's also integrated into Azure. Terraform can leverage your investment in ARM templates. If you have built out ARM templates that you're using, Terraform has a resource that you can use to call those ARM templates and use them if you were to try to move to Terraform. You wouldn't have to throw out everything you have. You can leverage it and kind of move slowly across to the new platform. This isn't the recommended way to run over a long period of time, but if you're transitioning from ARM to Terraform, you could do this. When we get to, Ricardo, when we get to the bit where I'm showing you the Terraform registry, I'll show you the kind of the history of it. I think it's every few weeks. It's a pretty regular release cycle, but I'll show you that. Okay, so Terraform, and this is kind of really the big win for Terraform, is that it's multi-cloud, same process. So if you're running on Azure and I know I pronounce Azure like 3 different ways. I'm terrible with that. But if you're running on Azure and you run with Terraform, the process of doing deployments is the same as if you're on Google Cloud. The code's going to look a little different because you have different resource providers, but it's the same general process. And a lot of people say, well, you know, I'm on Azure. That's really the only place I need to be, right? I'm a single cloud company. This is where we are. But, you know, things happen. You know, we have customers who say, you know, we love Azure. This is where we are. And then Google comes out and does some data lake thing they really like. And it's like, man, we have to leverage that. Or your company goes out and buys another company, and that company is heavily invested in AWS. So or even just something as simple as pricing, where you're trying to move around and really take advantage of the better price points across the clouds. So when you use Terraform, you're using that same process to manage your infrastructure in all these environments. Even if you're not multi-cloud today, there's a really good chance that you will be multi-cloud in the future. Finally, Terraform has great CI/CD integration. Here, this picture on the right is from Azure DevOps and the pipeline. You can see that there are actions for the DevOps using Terraform right there. You just drag it and drop it in. There are GitHub actions for Terraform. Terraform is built into Circle CI. For any other CI/CD process that maybe doesn't have a native Terraform integration, HashiCorp is managing a Terraform Docker Hub Docker container that can be integrated as workers on all these platforms. So HashiCorp Terraform is really built for CI/CD integration and really automation in general. So this is kind of a picture of the workflow of Terraform OSS, the OSS being the open source Terraform product. In the middle here, we have a command line binary sitting on your desktop or sitting on your CI/CD platform. And it's running, you're getting your code from GitHub or Bitbucket or Azure DevOps, pulling that down. You can pull modules that you create. We'll talk a little bit about modules when we kind of do the example here. You can pull modules down from that your company develops from these VCS systems. And you pull down the providers from Terraform, and you run all this on your desk, and you tell these providers, I need to build, you know, the following things. Meanwhile, you're building a state file that is keeping track of what you build. It's mapping the artifacts in your code for what you say is a server in the code to what it is built in Azure, so that it knows that when you're talking about VM1 in your code, it's talking about server ID 1, 2, 3, 4, 5, 6 later. And then later, when you make a change to this code, it's going to look at Azure and say, okay, here's what I had in state, what I'm managing. Has anything changed here? And then it's going to look at the changes in the code and say, this is our new desired state. And it's going to put that in place. So that's basically how Terraform works. So now I'm going to jump in here and show you a little bit about what Terraform looks like. First, we'll jump over to the registry and we'll look at kind of Ricardo's question. The Terraform registry is going to show you all of the providers we have. There are different levels. There's official, verified, and community providers. You can see all of the different things that we're able to automate with Terraform. We have 11 pages of them, 541 on the list. All sorts of different things, right? We have network providers. We have Cloudflare CDN. We have Akamai. So there's all sorts of stuff. If we go into Azure and look at Azure's provider, we can see it was last published 7 days ago. We go to the documentation section. It'll show us all of the things that we can automate, all of the resources that we can build, and samples of what the code looks like to build these resources. So like I said, it's extensively documented. All of this is open source. So if we want to go and we want to look at the source code for that provider, we can. And then if we want to look at the releases, you can see that the releases are about every 7 days. This provider is co-developed between HashiCorp and Azure. So it's not us just trying to watch and guess what Microsoft is doing and building this out. We work in close concert with them in the development of the provider. So now let's go and look at a couple of Terraform projects. These are a couple of them. Usually you're developing Terraform in any kind of regular code development environment. Visual Studio Code is great. It's got a plugin for Terraform to allow us to do linting. So within Terraform code itself, we have the provider that we're using to tell Terraform where we're building this information. We've got resources. A resource is something that you want to build. And Terraform is going to build any resources it sees in any of these TF files. So for this particular project, I built out infrastructure in different code files to make it easy to kind of follow what I'm doing. All of my compute is in this file. All of my security is in this file. My network is in this file. And these tie together by taking these attributes that you're passing in, and you're passing in attributes of the other resources that you're building. So for example, here I'm building my resource group. And then in my network section, when I'm building my subnet, I'm passing in the resource group name of that resource group that I created. And this allows Terraform to build a dependency tree. So Terraform knows what it needs to build in what order. You don't need to be concerned about that. You just kind of write out this code and Terraform does what needs to be done. So when we look at this, it looks like a lot of stuff, right? There's a lot in compute. There's a lot in network. So let's go and let's look at another Terraform project that's using modules. And if you remember, when I talked about modules, I said that Terraform is able to be organized into reusable best practice chunks of code. And most of these providers provide modules for that. So in this case, we're looking at modules provided by Microsoft for Azure for building out servers and building out a network. Now over here, when I was building out resources, I went and I looked at the documentation and said, this connects to this. And I built out a subnet and I built out network interfaces. I built out public IPs. With the modules, I can just kind of look at this grouping that has been published and just say, I want to use this module, and then look at the documentation for those modules, and it'll tell me what this module will build. So if I want to build compute on Azure, instead of building out all the resources myself, which I could go to the module registry here and look at Microsoft's module, and it'll tell me what I need to pass in, the optional inputs of what I could pass in, and generally how the system works. So in this case, I want to build a Linux VM, and I want to build a network, and I want to build myself a resource group. So a couple of things before we get started and run this. Terraform is going to allow me to set variables. These are things that can be passed into the Terraform code to kind of make it reusable, to allow you to run the same code in a different way. In this case, I've got a prefix that I'm using, and I'm sending that in. And if you notice, I'm kind of throwing that into what I'm building out so that I'm naming things that way. I've got the location that I'm using is going to be set as a variable. I've got a list of host names using this file. This is a way to push those variables into an execution. There's other ways you can use environmental variables or command line arguments as well. But in this case, I've just got them in the file, and that's going to go ahead and provide this. So now I've got this Terraform environment. Let's build something. So I go to my terminal here, and Terraform has a few different commands to run, but the two big ones, the first one is called Terraform plan. I just run the Terraform executable in the folder where I have my code, and I run Terraform plan, and Terraform plan is going to tell Terraform to look at the code, and if there's anything in state from a previous run, determine what we're going to build. It's going to tell you what the outcome of running this code is going to be. It's going to build that build plan, but it's not actually going to change anything. It's not actually going to execute anything. So there's a little warning here at the bottom because this module is using an older code standard for interpolation, but it's not an error. So if we look at this, it's showing me what we're going to build. Now, if you remember in the code, right, we had really three things: the network, the module, the server module, and we had the resource group that we're building. But when we look at the Terraform plan output, there's all sorts of other things, right? There's a VM, there's a public IP, there's network security rules, and that's because all of that is kind of hidden in that module. So the developer doesn't necessarily need to know everything that's happening. You can publish a module that says, hey, we need to build VM, build it this way, pass this data in, and it'll take care of everything that's going to build. So I run Terraform plan, and Terraform plan tells me, if you run execute, I'm going to build 11 things. I'm going to change nothing that exists, and I'm going to destroy nothing. So we'll go back in, and now we'll run the second Terraform command. We'll run Terraform apply. And Terraform apply is going to tell Terraform to run that plan again, just to make sure that nothing has changed. And then it's going to give me a chance to review that plan and say, okay, are you sure you really want to build this? At which point I will say yes, and it will build it. So it's telling me, we're going to build 11 things. We're going to change nothing. We're going to destroy nothing. You sure you want to do this? Yes, I am. So now what Terraform does is it builds that build plan, and it's going to reach out to the API for Azure, and it's going to build everything I need. It's going to do it in a multi-threaded environment. It knows what depends on what based on that dependency tree. So it's going to go out and build as many things in parallel as it can and kind of throw everything that needs to be serially done serially. And it's going to go ahead and do that build. And it's doing this now. So while this runs, over here we have the Terraform state file. And that state file is what I was telling you before. That kind of keeps track of everything that's been built. So if you look here, you can see we're building these things. You know, these all have IDs within Azure that identify the objects. And the Terraform state file is keeping track of what those IDs are, and it's mapping them to these names that it's built. So you see it's building VM Linux 0. The Terraform state file is saying, hey, just so you know, VM Linux 0 is, you know, Azure ID 123456. So when we come back later and try to make a change, it'll map the changes in the code back to the reality within Azure. So while it's building this VM, let's go over here and look at our resource groups. And we'll see this is the one that we just built, csmith test modules demo resources. We know that's the one we built because I have that variable, and that variable that I used is telling me, wait, I guess it was in that file, is kind of telling me what I'm building. That csmith test modules is being kind of built out as that name. So that builds out csmith test modules demo resources. You can see the things that we're building. As we look at the objects that we're building, you can see it matches to the input that we put in, some of those tags and whatnot that were in our code. And when it's done, the output variables that we've defined, we said, you know, hey, when it's done, I want to know that Linux server's public IP address, and then it outputs that for us. So now we've built our infrastructure using Terraform. And if we wanted to go in and make a change, we can. So we've got this in existence. Let's go into our vars file, and we're going to change this server count variable to 2. And that variable is being passed into this Linux servers module, telling it how many IPs we want and how many instances we want. So if we go back to our command here, now that we've saved that, we say, you know, hey, Terraform, apply our changes. And Terraform is going to do what it did before. Now, before there was nothing in state. It hadn't run anything, so it didn't have anything that it was managing. In this case, it's managing all the things that it built before. So the first thing it does is it goes out and says, well, what's still there? Because somebody could have deleted something and it might have to go out to rebuild something. In this case, it's not going to change anything. It's going to make 4 additions because it recognizes that there's new things. And it's saying, I'm going to need to build a new virtual machine. I'm going to need to build a new public IP. I'm going to need to build a new network interface. So that's what it's going to do. So if I tell it Terraform apply, say, yes, please do this, Terraform is not going to make any changes to anything it had in place. It's going to go ahead and build the new stuff out. So that's basically, oh, what did I do? Okay. Okay, I forgot to make one quick change here real quick. That is my fault. I need to give it a new host name there. I'm trying to build a VM with the same host name and doesn't like that. But it'll go out and it'll make those changes and it'll build those new VMs and the new pieces that it needs to build. So that's kind of Terraform in the OSS, and this is the environment that is used when you make these builds, when you run Terraform. It's somebody working out of a command line with code that they have written here. They're running Terraform commands to do the push, or Terraform is kind of running within a CI/CD pipeline. Okay, so that is Terraform OSS. Does anybody have any questions before we move on? Just go ahead and throw them in the chat window. Next up is Terraform Cloud. All righty. So Terraform is a great thing. It's fast. It's easy to use. Those modules are giving you reusability. There's a lot of really cool stuff you can do with it. And everybody loves Terraform. Everybody loves how this works. Until everybody loves how this works. It was easy when you had one user working on one project, right? You had that state file that they're talking to that's looking at what had happened, but you need to make that state file highly available if more than one person is going to run that project. So you can take that state file and you can put it in like Azure Blob Storage, or you can put it in S3 or something in the back end. But you still have access to, you have to lock it down. You have to give people permission to that state file. Somebody's got to build that out. So if you have 100 of these projects, somebody's building out this blob storage. Somebody's got to give permission to developers to this blob storage. Somebody's got to keep track of it all, right? You have the same thing with these modules. Those modules are stored in GitHub repositories if they're not in the Terraform registry. Well, you have to give access to the developers. So if you have a new developer coming online, then you have to give him rights to those modules. Additionally, when I was running those commands, Terraform was using my Azure credentials that I had on my laptop that I do when I run like the AZ command line command. I had logged in with that, and that's what was being used to log into Azure to work. So now every developer has to have credentials to Azure. Every developer has to have credentials for those modules. You have to manage all of this state. So Terraform's a great thing and it's easy to work in, but when you start to put people together to work on it, there are definitely challenges. So you get these kind of questions. How do I onboard people and projects into Terraform? How do I share code and promote best practices? How do I create and enforce guardrails? How do I make it so that if Bob was working on that program I was just working on and I changed that value to 2 to make the total VM count 2, how do I make it so that if he didn't slip and type 222, it doesn't build 222 servers? How do I limit access to the providers? Maybe I don't want every single one of my developers having access to build VMs directly. You know, it's great that they're using Terraform to do it, but I don't want them to install the AZ CLI and do things that way. How do I audit it? How do I know what has happened? How do I know who's using it, how it breaks down, and how do I really automate the process? Really what we're talking about is how do I make Terraform an IT service that I can manage and give access to other developers in an easy way. And the first instinct is to build some automation around it. And I was the scaffolding guy at many, many previous companies where my management would come to me and go, you know, we really need to automate this thing, but you know, we don't really necessarily want to buy like an enterprise product. Maybe you could just write some code around it. And a lot of people go this way and some people are successful with it. The problem is you get this creeping tech debt. as features are added, you're adding features on your own, and you have to go back and handle changes in Terraform and changes in environment. I used to work at a place. I talked to the VP the other day, and I asked him, what was going on, basically calling back everybody I used to work with to see if they need to buy some fine HashiCorp products. And he said, we thought about using Terraform, but we kind of built our own around the OSS. I said, how did that turn out? He's like, the dude who built it left. And that's true. People leave, right? How are you going to maintain stuff if people leave? It becomes hard to manage. And when things are hard to manage, it becomes hard to tie a service level obligation to it. If you're saying to your developers, we're going to be able to have this service, it's going to be up, you're going to be able to use it, and we're going to maintain, the following key performance indicators for it. How do you kind of put your money behind that if, it's kind of all held together with Python code and duct tape? At 2 in the morning, what do? You don't have vendor support for it. So scaffolding, while it looks like a good option, it might be your next option off of something like command line Terraform. As you grow and Terraform becomes more important to your process, scaffolding is not the end all be all of where you want to be. And that's where Terraform Cloud comes from. Terraform Cloud and Terraform Enterprise. Enterprise is an on-site version of the Terraform Cloud software. Terraform Cloud is a software as a service version, seeks to kind of solve that problem. It wants to centralize all of the management pieces that go with Terraform at scale. It wants to centralize policy. It wants to centralize execution. It wants to let people use the process easily without having to manage all the millions of things that you might have to manage. Setting up new storage for state, giving people access to repositories, importing users. Terraform Cloud is looking to make that easy. So Terraform Cloud does this by offering a software as a service-based infrastructure, right? You don't manage it, HashiCorp manages it. It provides centralized auditing and reporting in the enterprise version, so you can build dashboards, giving you easy access to the logs and also aggregated information about usage. It provides a private module registry, and this is pretty important. The private module registry is much like that Terraform registry we looked at when I was building out those compute modules and that network module. The private module registry, though, stores your information. You're putting it in, GitHub or Bitbucket or something like that. And Terraform Cloud makes a connection with the credentials stored in Terraform Cloud to that. So now your developers don't need access to that private module registry. They're going to go through Terraform Cloud to get that. Terraform Cloud is going to keep track of things like versioning of those modules. So it makes it easier to use. Terraform Cloud also centralizes security. So you don't necessarily have to have your developers having access to Azure anymore. That access is going to happen through Terraform Cloud. Your developers are going to say, go push this out, and they're going to tell Terraform Cloud to do that, and they're going to look at the credentials, their Terraform credentials, and whether they have access to do that. And then Terraform Cloud is going to talk to the cloud providers for you and map out those security credentials. So now you don't have to give everybody access to the cloud providers, but this allows you to really expand who's working on infrastructure, right? Before, maybe you didn't want to give, all of your developers access to this cloud environment. Now you don't really have to. All you're doing is telling them to write code and then giving them access to a configuration within Terraform Cloud that'll push to a specific environment that they themselves don't have access to. Terraform Cloud also has something called policy as code. And we'll talk about this a little bit more here. But policy as code is these guardrails. It's going to look at the runtime environment, and it's going to look at the code that you're proposing to do and allow you to codify rules that say what people can and can't do. And it's going to allow you to selectively apply those rules to different projects so that different people have different guardrails, and you can establish what you will and won't allow in your environment. And finally, you have VCS integrated execution, which is GitOps. And I'll talk about that a little bit more when I do the Terraform Cloud demo here coming up. So this is really what it looks like with Terraform Cloud. Before, you had in the middle the executable and the user. Now you have different users of different types interacting with Terraform in different ways. You have developers who are talking to Terraform in the various projects. The projects are called workspaces in Terraform. You have the private module registry. You have operations people building those modules for those best in breed kind of golden templates that you want to use. Your compliance and security people are building those Sentinel policies that are telling people what they can and cannot build. And now all these teams are interacting with this software as a service component that is then itself talking to all of these back-end processes. So it becomes more of an IT service with centralized management that allows you to have a uniform way of dealing with infrastructure management across your environment. So really quick, we'll talk about Sentinel. Sentinel is that policy as code piece. Basically, there's an example of some Sentinel code here that is saying, if you build an Azure Linux virtual machine, it absolutely has to have a tag. You can attach this to your projects, and if somebody tries to build a virtual machine that doesn't have a tag, it won't allow it. Well, there's three choices. It can warn you and say you really shouldn't do this. It can stop execution and require an administrator to approve it, or it can hard stop and say, no, you are not allowed to do this. And there's all sorts of things you can do with this. You can build plans to say, you know what, for production, you can't build after 5 p.m. on a Friday and before 7 a.m. on a Monday. You can say, we are limited to the following size servers. And you can change that for each different project. So you could say, you know, these guys over here who are doing data science, they can use the really big servers. These guys over here who are doing a web app, they cannot. You can limit the number of things created. You can even tie it back to an estimated cost. So Sentinel is a really powerful kind of thing. So now I'm going to show you another demo. And we're talking about the GitOps kind of oriented approach. We'll look here. This is, actually, that's my GitHub page. This is Terraform Cloud. These are a number of projects that I have running in my Terraform Cloud organization, which is named CSmith. Each of these projects has different kind of security boundaries. I can give people different rights to these projects, different things they can do. The state file is stored within these projects. I've got a history of the runs from these projects and how they built. If I go up to the organization level, I can see the policy sets that I've built out. And when I look at my policy sets, I can see what workspaces that they're tied to. The rules that are built out in this policy set will apply when these execute. We've got SSO capability to be able to set up single sign-on to import users. And then I've got my private module registry over here where I've imported the modules that users can use through Terraform Cloud. They just kind of copy this code bit into their code and they're good to go. So when we look at the workspace that we're going to do now, it's called Terraform Azure GitOps. And this is a VCS integrated workspace, which means that it is tied to a project in GitHub. Doesn't have to be GitHub. It could be Azure ADO, it could be Bitbucket, but I'm tied to a specific repository here. And I'm telling it when a change happens to the default branch, which in this case is main, we want to trigger a Terraform run. Now I've tied certain variables. If you remember, I had variables in that project with the modules in that code file. Here I push them up to Terraform Cloud and I've kind of locked them in. So my prefix is going to be set here. My location is set here. I've got certain sensitive variables that I don't want people to be able to see. And I've got environmental variables, which are handling that authentication to Azure. So all the authentication and the communication with the cloud environment is happening from the Terraform Cloud environment, and all the authentication is happening here. My users do not need to have access to this web page. This is something that is being centrally managed by IT staff or whoever manages Terraform, and the security is set here. It can be set on a project by project kind of basis. So let's look at what the experience for this is like for a developer. Here I am, Chris the developer, and here's the project I'm working on for my Azure GitOps project. In the software development lifecycle for my company, we work out of the dev branch. We make changes in the dev branch, and then we create pull requests to merge those branches into that branch into the main branch, which is where our production code is. So in this case, I'm going to go in here and I'm going to go into my compute file. and I'm in dev, I'm going to make a change and I'm going to add a tag. And the tag I'm going to do is, it doesn't really matter. We'll call it priority. And the priority is going to be lots. So now our developer has basically pulled this code from, a Git repository. He's accessed the branch that we use to make that upgrade, goes ahead and saves it, and he goes in and he makes his commit. And his commit will be called priority tag. Except he will spell it right. And then we go in and we make that commit and we push that commit up to GitHub. Now, when we go over to GitHub, you'll notice the developer here did not do anything terraforming. He didn't run any Terraform commands. He didn't do anything terraforming other than write Terraform code. So when we go into GitHub and we look at the project, we see the dev had a push. We'll say that the rest of our developers have come in, they've merged their feature branches into dev. We're ready to move that code into production. We go in and we create a pull request. Now our process for pull requests, all of that is set within Git. This is our software development lifecycle. It has absolutely nothing to do with Terraform. We probably do this the same way for our .NET code. It has to have a certain number of reviewers. Pull requests have to be approved by specific personnel. There might be rules for labeling. All of that is set within your software development lifecycle. It has absolutely nothing to do with Terraform. In this case, our developers are just following their lifecycle. So we go ahead and create this. We're going to merge dev into main, and we're going to create our pull request. So when we create our pull request, the first thing we see is there's a check, an automated check happening. We'll check the details on that and see what's going on. And we'll see that Terraform Cloud has detected that possible commit into the main branch that it was watching, and it's going to run a Terraform plan. It's going to verify that what we were trying to do would work. It noticed there was one change. The next thing it's going to do, if we've enabled it, is to do a cost estimation. It's going to look at the endpoint for the cloud services. And this works not for every provider, but it works for the big ones, Azure and AWS and whatnot. And it's going to say, by making this change, your spend is going to change in this amount. And then it's going to check that policy check that I had that said, you're not allowed to build VMs without tags. It's going to look at that plan that was generated, and it's going to verify that all of the VMs that we're going to create are going to have tags, and it goes through and it says, yeah, okay, that was successful. So we go back here and we kind of wait for this to finish. It can sometimes take a second after the run finishes. And it says, okay, Terraform has checked it. It checked it against that the code is going to work. It checked it against the rules that we have put in place. That policy as code. This was a very simple policy as code example, but you can create many policies and make them as complex as you want. And it says, yes, we're ready to now make that change. So now somebody who is approved in your system to do that merge will go ahead and confirm that merge. And that code is merged in GitHub. Meanwhile, on the Terraform side, Terraform sees that merge and says, okay, time to step up. And Terraform goes back to its process, runs the plan again, runs the cost estimation again, runs the policy check again, but this time applies the change. So it's really kind of a powerful thing. It's like CI/CD in a box, but it's really all native. The process of actually setting it up really was just making sure that code was in GitHub and going through Terraform and saying, okay, these are the VCS providers I'm going to allow. In this case, I have one for Azure DevOps. I have one for GitHub. And then when I created the workspace saying, okay, I want a new project and I want it to be version control workflow and tell it what project in GitHub I want to connect to, what branch I want to watch, and bing, bang, boom. The advantage of this, the really huge advantage of this is the developers don't need to know anything about how Terraform works. They need to know how to write Terraform code, but they don't have to have access to the modules. They don't have to have access to Azure at all. They don't have to actually run a Terraform command. Everything is handled through your regular software development process, and all the control is at the top within Terraform Cloud. So that's kind of what Terraform Cloud is. And it allows us to build out this GitOps process where you're building these separate workspaces for every branch. And you can really tie it in because each one of these workspaces contains different policies, contains different variables, values, contains different security. So I can have the dev branch, when someone commits to that, build out into a dev environment that might use one Azure account, might use a variable that sets the number of servers. And then when they go to QA, I might build something out bigger. And that doesn't touch anything that's happened to dev. It's completely independent, and it's tied back to your VCS structure and your software development lifecycle. The prod branch might be bigger. It might have more checks attached to it. But it allows you to really build out a true kind of GitOps-based workflow from the cloud. So if you're interested in looking at any of this, this link here is for our downloads. You can just go to HashiCorp.com too. It's easy to find information about our projects. I'd encourage you to download Terraform and play with it. Also, some of the other projects that we had, I only mentioned them very briefly at the beginning. Vault, Nomad, Console, Waypoint, Boundary, all available here. You can download them and play with them, all open source. Terraform Cloud that we looked at, go take a look at that. Terraform Cloud is free. Some of the parts of it are paid usage. I think when you start talking about having multiple people over 5 working on a project, or when you start looking at that policy as code, the cost estimation stuff, I think those are paid features. But that VCS workflow that I built, you can do that out of the box with free Terraform. You can get in there and play with that right now. The HashiCorp Learn site is going to show you how to use it, give you a bunch of exercises to kind of practice with, to build things out with Terraform, look at some of the features and get used to it. And lastly, HashiCorp runs workshops regularly. Used to be back in the pre-COVID days, we'd fly around and go places and put people in a room, get like the first 50 people. But now with COVID and Zoom, we throw 250 people in a room and we do 4-hour deep dives on this stuff, punctuated with hands-on labs that we break into small groups with TAs who kind of work with you and answer your questions and talk through this stuff. So if you want to, if you're interested in what I was talking about, any of this stuff, it's really easy to jump in to the command line Terraform, to the Terraform Cloud part, or really any other of the products that HashiCorp has to help you speed up your cloud journey. That is what I got. Does anybody have any questions?
Come on, people, don't be shy. If you have questions, ask them now. Great presentation, Chris, by the way. Thank you very much.
Oh, thank you, Bill. Thank you for letting me talk to you guys.
Yeah, thank you. It was really good.
All right. Well, with that, then back to you, Bill.
Okay, great. Thanks again. Like I said, Chris, thanks a lot for the presentation. Let us know if you're in the audience, let us know what you thought of this presentation and what you're interested in for future meetings. I do want to, one of the questions that came up on direct discussion was how to come up to speed on Azure. And this gives me a chance to give you a quick look at our YouTube channel. And there's a couple of presentations out there that are good for people that are new to Azure. Let me just share my screen. Let's see, share, come on, share screen. When you see it, you folks see the screen? See the YouTube page?
Yes.
Okay, great. For the people who are new to Azure, Tim Warner, who's the Microsoft MVP and board member, did a great presentation 7 months ago, how to get and stay current with Microsoft Azure. I definitely recommend that. Some of it may be a little out of date, but you know, where you go for learning information is doesn't probably change as much as Azure itself changes. So definitely recommend that. About 5 months ago, I did an Azure what to use when presentation. So that's pretty good. I'm kind of biased, as you might suspect. And we've had presentations on Windows Virtual Desktop, on Azure DevOps, security, a couple of presentations on security. Tim actually interviewed me about what it's like to be an Azure Solutions Architect. So I think that's a good one too. And then there was one on Platform as a Service that was focused, geared for developers and focused for developers, and Azure networking. So as you can see, we kind of spread it out in terms of topics and experience levels. But again, if you have something that you're interested in us covering in a future meeting, let us know. One of the good things about being remote is that we're not really restricted to people in our geographic area. We can get people from other parts of the country, even in some cases other parts of the world. Although we have had a problem with the time zone differentials. So that's what I wanted to give you in case you're looking for resources. This one will be posted in the YouTube channel in a couple of days, probably. If I don't get to it over the weekend, we'll get to it Monday. And that's really it. Anybody have any last minute questions, comments, feedback, anything? I'll stop the recording if you want, so that we don't get anybody incriminated. So let me stop the recording.